Well, good morning, everybody. Once again, Jose Della Portilla here with Ream Manufacturing. And thank you for joining us today on our webinar for A2L Steps to Success. Our goal with this webinar is to educate you on the most important things you need to know for successful adoption, installation, service, and maintenance work for A2L for systems utilizing A2L refrigerants. By way of introduction, I am Jose Della Portilla. I'm the Senior Manager of Education and Training here with Ream. I have been in the HVAC industry for going on 30 years with experience in installation, service, sales, technical support, training. I've been really blessed to have a very diverse career that's allowed me to participate in a lot of sides of the business. So I'll be presenting with you today, but I am also very excited to introduce to you my co-presenter, an amazing instructor, very knowledgeable, knows what he's doing a lot. So I'm going to turn this over to Don and let you give yourself an introduction here, Don.
Hey, thank you, Jose. Appreciate it. Good morning, everyone. Comores thanks you, Jose, and the Ream team for allowing us to help support this 454B product and the Ream product. My name is Don Gillis, as Jose said. I'm a technical trainer for the Comores Company. I've been in the industry for just a little over 31 years, I believe. 24 of those years I worked out of a truck. I've had roles as an installer, service technician, and the last 8.5 years of my career, I was a service manager. I am a licensed journeyman in Allen County, Indiana, which is the city of Fort Wayne. Very passionate about what I do. I've helped train thousands of technicians throughout North America. Very passionate, and just to throw a bone out there for my son in case he's listening. Our oldest son is actually a licensed contractor, HVAC contractor in the city of Fort Wayne. So enough about me, Jose. I'm going to turn it back over to you.
Awesome. Thank you so much, Don. Okay, so we've got a lot to cover here today, but it should be very easy for you to understand, very easy for you to grasp, and we're going to have some amazing takeaways that you can go to a website and download free of charge. This information that we're sharing is open to anyone. Our goal with this webinar is not to teach you about how Ream products work or how Comores products work, but to teach you about the trade, because we really firmly believe that as one of us gets better, we all get better. So our goals in this training are this. First, we want to increase technicians' awareness of A2L refrigerants and their use in that modern HVAC equipment. Second, we want to review safety, transportation, handling, installation, service best practices when using A2Ls. We also are going to give you a little quiz at the end just to test your knowledge, to see how you are with A2Ls and how ready you are for this transition. So our agenda is as follows. First, we'll do a quick overview of what A2L refrigerants are, a little bit of information about why A2L refrigerants. From there, we're going to talk about A2L as it's applied to comfort cooling. We'll then cover some myths and facts that are very important for you to know, because these are the things that, as Don and I have been training, we've heard people feel concerned about. So we're going to address those. From there, we're going to talk about changes that are occurring to refrigerant cylinders. And then from there, we'll move on to installation best practices. We'll then move on to safety so that you're aware of everything that you need to do. We'll tackle those review questions. And then at the very end, we'll go ahead and have a summary where we wrap up and then answer any of the questions that you may have. So I just wanted to give a plug here about something that we need to consider. One of the reasons we're making a transition to A2L refrigerants is to better our environment, to improve our sustainability. And we need to focus on this because homeowners out there today, business owners out there today are looking for sustainable options. Now at Ream, we're really dedicated to sustainability. You can take a look at our sustainability tracker here. Notice on the left that we have 18.5 million tons of CO2 emissions have been offset by our products. We've reduced 327 million tons of waste at our plants by focusing on initiatives to get us to a point where we have zero waste to landfill. And we have trained over 300,000 plumbers and contractors on sustainability and the benefits it provides to their business. And now we're going to go ahead and go into a section focused on A2Ls with a quick overview of what they are and why we're using them. So for that, I'm going to go ahead and turn the time over to Don.
Thank you, Jose. Hey, listen, we all know what a refrigerant is, right? It's a chemical compound capable of repeatedly changing its state from a liquid to a vapor back to a liquid while maintaining its chemical stability. That's still going to hold true with A2L refrigerants. It's nothing's going to change there. It has a relatively high latent heat carrying capacity and a low boiling temperature, and that's key for any good refrigerant. They don't just pluck these things out of the air. But some refrigerants are better for our environment, and that's the things we're going to talk about today. Next slide. So environmental challenges driving the industry transitions. On the right-hand side, we can see the Montreal Protocol had to do with CFCs and HCFCs. Remember, that was a phase out. That had to do with the ozone. It seems like a long time ago we took our EPA card, at least for me anyways. On the left-hand side, you'll see the Kigali Amendment. Now that focuses on HFCs, where the Montreal Protocol did not. So they literally had to make an amendment off the Montreal Protocol. They called it the Kigali Amendment because that's where it was signed, and it's a phase down rather than a phase out. Okay, that's key to remember. This has to do with global warming potential. Okay, next slide, please. Now, just a quick snapshot of this. In the red box there, from left to right, you'll see it in the early 1900s. We had CFCs, R12 or 1930s, pardon me, and it had the highest of ozone depletion, and it also had the highest of the global warming potential. All right. In the 50s, we saw good old R22. Still had that letter C in there in the front, HCFCs, the chlorine's still there. So it lowered the ODPs, the ozone depletion, but it still had high GWPs because at the time the science wasn't there. It's kind of like Mike, comparison to that is we were really concerned about asbestos. We removed that, and then mold came the new asbestos basically. In the 1990s, we saw 410A. It's hard to believe that 410A has been around that long, but it has. It's HFC. So they got rid of that chlorine, no ozone depletion, but still had high GWPs. Now, everything you see in that red box, it's classified by ASHRAE Standard 34 as an A1, and we'll deep dive into that a little bit more, what that means, okay? Just to let a little cat out of the bag, it's going to mean that it's non-toxic and it's non-flammable, okay? Now, moving to the right where we're at today and the future of this refrigerants, we see HFOs and HFO blends. If you're not using some industrial or natural refrigerant moving forward, you're going to be using a lot of HFOs and HFO blends. Examples of that like would be the Chemours product R454B, 454C, and 454A. Now, when we change those letters, well, all we're doing is changing the composition of what the ratio is in the refrigerant. They'll still be the same two components, but it'll just be a different ratio, whether it's 80-20, 50-50, 60-40, or what have you. And just a fun little fact, if you see a capital letter behind any refrigerant, that tells you that's a blend. And that's an ASHRAE Standard 34 A2L. And I'm going to refer to that as a new kid on the block as we move forward. Next slide. Okay, this slide describes key points of A2L refrigerants. For the most part, you can read through the bullet points. The key thing about the chart on the right to note is that the refrigerant classified as A series are the lower toxicity, okay? I never like to say look, no toxicity because anything with enough parts per million, if it's not well ventilated, will asphyxiate you. That's important to know. The letter B series refrigerants like ammonia are toxic, obviously, okay? The lower the number following the letter explains its flammability. So 1 is good, 3 is very flammable, okay? A2Ls are a low toxicity and are classified as mildly flammable, kind of a lazy flame, if you will. You might hear some folks, if they get down in the weeds, a low flame propagation. Now, throughout this presentation, we're going to cover how hard it is to ignite them. Many people confuse A2Ls with A3s, and that's a terrible thing to do because there's a lot of misconception out there. You can't put all flammable refrigerants in one bucket. It's night and day. A3s are hydrocarbons like propane and butane, which are both used in HVAC and refrigeration equipment with a low charge volumes like refrigerant and RV style air conditioners. A2Ls contain no hydrocarbons. I want to repeat that. A2Ls contain no hydrocarbons and are difficult to ignite in normal situations. Next slide, please. So here we're looking at this chart here, and what this chart's basically telling you is where we came from global warming potential. Notice on the left-hand side, you have the ozone depletion. So we went from R22 to 410A. We got rid of that ozone depletion down to 0. But notice when we moved to R22 to 410A, we went up in the GWP. Again, the focus at the time was the hole in the ozone. That's where the science was telling us. Again, asbestos mold. It was kind of that. It wasn't until later on that we got that under control that we started to realize this global warming potential. The temperature started to rise. So then we moved from we're moving from 410A to an HFC to 454B, an HFO blend. And that's what we're here to talk about today. Look, notice the global warming potential from 2088 to 466. That's a big deal. I mean, just that move alone from 410A to 454B, if you care to know, is a 78% reduction in GWP. That's huge. Next slide, please. So blended refrigerants. Most refrigerants we use today are not a single element, but a blend of two or more refrigerants. An azeotropic blend contains two or more refrigerants, but these refrigerants boil at the same temperature. They act like a single element. When looking at a pressure temperature chart, there is only one scale. Now, azeotropic blends have two or more refrigerants, but they boil over a range of temperature that's called glide. If you look at a PT chart for these refrigerants, the high side and the low side will each have their own temperature scale, bubble or dew. The high side scale is used to calculate subcooling, while the low side scale is used to calculate superheat. Remember, bub for subcooling and dew for superheat. Zeotropic refrigerants are subject to fractionation if there's a leak in the system. Fractionation is when the refrigerant in the blend leak at an uneven rate. The lighter the refrigerant leaks out, first, changing the mixture. This is more prevalent in mixtures that have a high degree of glide. That's very important to understand, okay, because all systems have some type of fractionation when they shut down. I shouldn't say all refrigerants. I should say all blended refrigerants. The key there, okay? Um, uh, the zeotropes have a very low glide, do not suffer from fractionation, and can still be topped off if leak occurs like R454B. So there won't be any concern there. The final type of blend refrigerant is known as NARMs, or near azeotropic refrigerant mixture, and they are blends of two or more refrigerants have boiling points to similar that so similar that they act like an azeotropic with very minimal fractionation. 410A would be an example of that. It was like a half a degree. We never saw a bubble or dew point on our PT charts. Pretty easy to work with, and the same is going to hold true for 454B. Next slide, please. So I want to look over this real quick on this review on this. We start in one. To be fair about it, we're showing three refrigerants up there, okay? We're going to start with 410A. The global warming potential is 2088, as I said earlier. Moving to the right in that same red box, we see R32, global warming potential of 677. And then we move over to 454B. The global warming potential is 467. So either way you go on that, you're going to step down quite a bit from that 2088, right? Now, when it comes to glide, down at the next box, colored in red, glide, as I said earlier, it says 0.1, it's less than a half a degree. R32, obviously no glide because it's a single component. And then R454B is going to be approximately, this is approximately now 1.4 degrees Fahrenheit of glide. Again, won't be a factor in topping off or those kind of things. 410A was 12% more efficient than R22, which was a big deal at the time. R32 is approximately 12% more efficient than 410A. And then 454B is approximately 5% more efficient than 410A. So all good options, and whichever way you go on those two. Next slide, please. Now, we say A2Ls are new to us, but not necessarily new to us, okay? They're all around us. If you bought a car in the last 6 or 7 years, if you didn't know, 9 out of every 10 cars today are made with 1234YF, a Chemours product. It replaced 134A. And the reason that was huge is because it had the PT chart, the 134A and the 1234YF molecule literally are almost like for like. Literally, they're so close. It was complete change. There was nothing actually changed on it. The other thing is I always point out to training is this: why is the automobile industry so far ahead of us? Well, it's an easy answer. They've been putting higher flammable fluids underneath the hood of a car for years. So that transition was really, really easy for them to do. And like I said, 9 out of every 10 cars today use 1234YF. R32 in the center on comfort cooling, we've been using A2Ls around us there. If you bought a P-TEC unit like the Frederick in the picture there, or a window unit, or a dehumidifier, more than likely in the last 6, 7 years, you've been using A2Ls, been around it, and you just didn't know it, or maybe you did. And then we go to the A3s. A3s is a 290 propane. We have like R600 subbutane used in household refrigerants, freezers, used in commercial refrigeration equipment. The thing about 290 is, because I taught a lot of hydrocarbons prior to come here, is that propane that we use in our grill, same flammability. The difference is, if you don't know, when they use it in refrigeration, they do away with the stench because it's too impure if they put the stench in there. So it's a little trickier for those technicians to work around. They can't smell it. So, but it is night and day. Next slide, please. Let's talk about this molecule, HFO molecule. Okay, I want to, for the record, I'm not a chemical engineer, but I understand this fairly decent. Okay, on the left hand side, it's a R134 molecule. It lasts about 14 years in the atmosphere. It is an HFC. On the right-hand side, what took the place of the 134A in the automobile industry, and this will be in a lot of the blends, including 454B, is good old 1234YF. Now, compared to 14 years, it stays in the atmosphere for about 11 days. That's why we're here today. That's why we're moving to A2Ls, okay? It's classified as an HFO. And if you want to know, or if you teach classes out there to know what an HFO is, obviously it's the O is an olefin, but what's really an olefin? The olefin is in that blue bubble that you see around those two atoms. And basically, I often say an HFO is like a HFC in disguise almost. And what the scientists found out years ago, if they took those two atom carbons and connected them, and instead of using just one carbon atom, putting two carbon atoms next to each other, and they call that double bonding, that it breaks up much quicker when it gets in the atmosphere. It becomes more unstable and doesn't stay in as long. So that's a good thing. So that's where the science has led us today. Okay, next slide, please.
Awesome. Thank you so much, Don. Okay, everybody, great information. And again, we're going to keep diving in more. So as you have questions, throw them in the chat box. We're going to get to a point where we can pause and take a look at what's going on. Preferably, I'm sorry, not the chat box. Please throw them in the Q&A tab. It's just easier for us to see. So as we're looking now at the next section, A2L and comfort cooling, a few things we want to focus on. A2L refrigerants, we're going to be looking at those that they apply to comfort cooling, not process, not industrial, not manufacturing. There are multiple refrigerants out there, but we're going to be focusing on A2Ls and not A3s. Again, as Don said, A3s are used in some HVAC and refrigeration equipment, but it's very limited volumes of charge. Okay. There's two primary refrigerants that are A2Ls that you're going to see. One being R454B, and then the other being R32. We're probably going to see those in the industry for a while together. And what we see a lot of R32 being used for is one of the big brands uses that, and then a lot of your imported products are using R32B or R32, I should say, because they were implemented years ago overseas in Europe and other countries. Now at Rheem, we've chose R54B as our primary refrigerant, but again, there's going to be some products out there that still have R32. Why did we choose R54B? The bottom line is the chemical and physical properties are very similar to 410A. Similar temperature pressure profiles, thermodynamic properties, material compatibilities, oil types, similar system architecture, so your systems aren't going to change dramatically as we build them. It does meet regulatory requirements. It's a non-ozone depleting for non-ozone depleting requirements. It's GWP as low as 467. Extremely close performance to 410A. And again, I want to stress compatibility with POE oil. And so what you're going to see is when it comes to service and installation, a lot of what you're doing today is going to be exactly the same. So when we say similar to R410A, I wanted to show you something here. On this chart on the left, you see temperature, and then you see R22, 410A, and 454B being the pressure scales. Now, pressures are going to change, but one thing that doesn't really change in the comfort cooling business is that we're typically looking for an evaporator temperature, or what we call a saturated suction temperature, of somewhere around 40 to 45 degrees. At 40 to 45 degrees, R22 came in at about 68.6 psi. And everybody would round up and say you charge to 70 psi. Okay, at R410A, that suction pressure changed to 118 psi. Then when we jump up to R454B, I want you to notice the pressure actually went down. So not much change in the operation of the systems. This is why those pressure temperatures are so close together. Is going to be real convenient for you, and we'll talk about that in a few more slides. Now, as we look at the high side of the system, we're looking at what we call the saturated liquid temperature. And on average, we're shooting for somewhere around 125. That's an average number. Things can change based on system design, efficiency, variable speed fan motors will affect that stuff. But if we're looking at 125-degree saturated liquid temperature on R22, that high side pressure was right around 278. 410A, we're looking at about 448 was the pressure. And 454B, you see that decline in pressure again, but very, very similar at 426. Again, showing you this because not a lot of things are going to change. So why 454B? Why do we pick 454B as our primary refrigerant? I'm not going to read through all of these lines, but I'm going to focus on the ones that are different. So if we look at the second line, R454 has a GWP less than 500, which is the lowest practical GWP for a typical residential system. Yes, it has it. R32 is slightly higher. As we move down to the next line here, it says discharge pressures are lower than R410A. 454B, yes. R32, no, they're a little bit higher on the discharge pressure. Nothing that's going to change the game forever. It's just a little bit of a different operation. Discharge temperatures are closer or lower than R410A. Yes, so discharge temperatures and pressures are lower with 454B. Combine that again with that lower GWP number, it's a logical choice. So now we're going to go ahead and walk into the myths and facts section that we talked about. So Dawn and I are going to go ahead and alternate between these. So let me go ahead and get to the next slide. And Dawn, you want to walk us through this one?
Yeah, sure. So let's start at the top here. Myths and facts. Myths: A2L refrigerants are likely to cause a fire. Well, the fact is there are no hydrocarbons in A2L refrigerants. That's the first point. The fact, the amount of A2L refrigerants needed in the air to ignite is much higher than the amount needed for A3, quite a bit. And thirdly, the fact is it takes a tremendous amount of energy to ignite an A2L refrigerant compared to an A3 refrigerant. Open flame or a strong electrical energy source, for example, will not cause it. And last but not least, if an ignition even takes place, A2Ls have a very lazy flame, and we'll talk more about that as we move along. And as soon as the heat source removed, the flame extinguishes itself. You add air, you have to have that perfect concentration. Lastly, on this fact, compared to propane and natural gas, A2L refrigerants have a much lower flammability risk due to. That's true. Higher LFL, which means it's a less chance of getting igniting, lower flammability limit, must reach higher concentration to become. So in other words, it takes a lot more of the A2L refrigerant in the air mixture to cause the flame. Just a little bit of propane, as we know from using our gas grills. It has a higher MIE, minimum ignition energy. What kind of force does it take to ignite it? Like a striker, if you will. Okay, is it just from static electricity from the carpet, or do you need an actual, like a striker that welders use? And then lower heat of combustion, less energy released if it is burned. Okay, that's very important. And then lower burning velocity. Flames spread a lot slower at the speed they spread. So next slide.
Awesome. Thank you, Don. So this is just kind of covering what Don was talking about when we talk about lower flammability limits, LFL. We're not going to dive deeply into the chemistry that goes behind it, but what I want to show you, LFL, that's the amount of refrigerant that needs to be in space for combustion to take place. With propane, you only need 38 grams per cubic meter. With 454B, the Opteon XL41, you're going to need 297 grams per cubic meter. So you need a lot more refrigerant to have an ignition event. So that's not something that's as critical as people think. If we look at it again, the higher the LFL or lower flammability, the lesser the risk. So let's go ahead and go take a look at this next slide, Don.
All right, we're going to talk about minimum ignition energy, MIE. Okay, MIE is defined as the minimum electricity energy it takes to ignite a fuel-air mixture. Okay, you have to have the right amount of fuel and the air, and then you need some type of ignition, right? And that's what MIE is. Notice how much higher the MIE is for 454B compared to propane R290 is what we're saying here. In this higher MIE, the lower the risk of the ignition invention. We're not here to beat up 290 by no means, but we want to get rid of that misconception that there's hydrocarbons or propane inside these A2L refrigerants. Go ahead, Jose.
Awesome. Thank you, Don. And just as a piece of information for everyone out there. On this slide and on the next few slides, you're going to see that QR code in the lower right-hand corner of the screen. If you scan that, it'll take you directly to a YouTube video where there's a gentleman showing you the different A2Ls and A3 refrigerants and just how easy or hard they are to ignite. Really great video. So take time, scan that QR code. It'll be on this slide and it'll be on the other slide coming up. So as Don mentioned a little bit earlier on that first slide, burning velocity, the strength of the flame, right, or the spread, how fast that flame rolls. And if we look at R290, well, that's at around 46 centimeters per second. And if we look at 454B, 5.2 centimeters per second. So if you look at these two images on the bottom, and again, there's that QR code that you can scan for the video. And don't worry if you didn't catch it. You're going to get a link to a site where you can download a PDF version of the presentation. You can scan it in your PDF. But on the left image, you see a bottle of A3. He takes a striker and it ignites, and it's a very strong, large flame. Next to it, the A2L refrigerants, as he's striking it, you see no ignition is taking place in that torch tip. So it is a very lazy flame. Another thing to mention is that when that source of heat goes away, so does the flame. So just want to share some of that as insight for you to know about. Okay, Don, you want to walk us through this one?
Sure, very good, Jose, by the way. Heat of combustion. How much heat is released when the refrigerant has been ignited? It's expressed in kilojoules per gram. And notice how much lower the heat of combustion is, again, for 454B as compared to R290. The lower heat of combustion, the lower risk of the ignition event in place. And just for a fun fact is any refrigerant with enough heat to it will combust. Okay, so it's not like A2Ls or any extreme as far as compared to A1s. Just for the knowledge there. Okay, go ahead, Jose.
All right, thank you, Don. Okay, so then this next myth, I'm going to walk you through a few slides. There's several of them, and you may think, okay, this is kind of getting repetitive, but I wanted to show you some really cool findings. So AHRI put out this report, the AHRI report number 8017. And what it did is they went ahead and tested the refrigerant. They created a perfect storm, right? The perfect space for ignition to take place, which we'll call stoichiometric combustion, right? They created a perfect place for that. And what they found is that through different heat sources, they couldn't get ignition to take place. Now, as I show you these next slides, I do want to be clear that you will not see the number R454B on these slides. But that's because R54B is that blend that Don talked about of R32 and R1234YF. So if you could ignite either of those, you could ignite R454B. So just so you know, that's why it's not on the slide. So here we see an example. They create a condition with a sealed box. They've got oxygen, they've got refrigerant, and now they're inserting a flame. They've got a lit cigarette in this box. And conditions are what we call stoichiometric, meaning almost perfect conditions for ignition to take place. And inserting that cigarette didn't cause ignition. So move on to the next one. Here we got a barbecue lighter constantly lit. So we've got a large open flame. You can see it on the left-hand side. Nearly perfect conditions, none of the refrigerants could ignite. All right, here we go. We've got an electrical plug and a receptacle. We created an apparatus, they created an apparatus that plugs in and out an electrical cord over and over again so we can get that spark, we can get that arc. And as you can see, ignition didn't take place. Light switches. Created the mechanism, flipped the light switch on and off, open components to the screws there. No ignition source, no ignition took place. Okay, here's one people have been concerned about. What about my drills? So here's an electric drill. This is a non-brushless drill. So meaning it's not brushless. It has that little arc that's generated as the drill turns in the back ventilated end of the motor. Perfect conditions, that could not create a flame. No ignition event took place. Okay, now there's a blender or a hand mixer, right? Not that I think any of you are carrying a mixer with you in your service truck, but hey, if you are, who am I to judge? But when they place this mixer, which again is not a brushless motor, in perfect conditions, it didn't ignite. All right, here we go. This one was one of my favorites to look at. Here we took a piece of flint, we took a grinding stone attached to a wheel, ran it consistently. So as you see in the lower right-hand side of that image, constant spark going with the refrigerant and the air, and no ignition took place. Hair dryer, right? 1600 watt, 110 volt hair dryer, no ignition. Toaster, nice hot toaster. You can see them glowing red hot, no ignition. An electric burner plate that you would plug in, they drop that into a perfect mixture, and again, no ignition. Here we go. A ceramic heater, right? A little tower heater. Temperature coming off of that was 170 degrees Celsius, so that's a lot higher on the Fahrenheit scale. And as you notice, no ignition. The reason for covering all of this is to let you know these are some pretty strong sources of heat, and they couldn't ignite the refrigerant. So I want to thank you for listening to that. Now, Don, here's another portion of why they're less likely to cause a fire. Can you walk us through this?
Absolutely. I'm still chuckling inside with the person with the blender on their service truck, Jose. That was a good one. So let's look at these safety features on the tanks, okay? We all know on the A1 tanks above, the orange tank there, the 404A, there we had concerns about what if these ruptured discs go off. Now, it's not a set temperature, as we know, but we've always taught, usually if you see a trainer teaching about the ruptured disc of the A1, the way they usually go about that is like 130 degrees or above. But it's really about pressure, what the pressure setting is, because obviously that's going to be different for each refrigerant, pressure temperature relationship. But the way the ruptured disc works on the A1 tanks now is gets above that heat in your van or out in the driveway if you're down south, that pops out of there and lets release the whole charge to prevent something catastrophic of that tank turning into like a giant hand grenade. When we decommission those tanks, we're supposed to puncture a hole in that ruptured disc and remove it, right? Now, the fact is on the A2L tanks, we're not going to have that issue of just releasing all that A2L refrigerant, even though we've told you how hard it is to ignite this refrigerant, and much closer than A1 took an extra step here. The A2L cylinders do not have a ruptured disc. They have what we call a relief valve. And the way relief valve works is they'll release just enough pressure off it to take it out of the danger zone, if you will, okay? It's like it exceeds 600 PSI on that valve, opens releasing refrigerant until it drops below the relief point. So even though it's much less flammable than things in your truck that you carry now, settling, for example, they still took that extra step on those tanks, okay? The entire contents of the cylinder will not release, making it hard to reach the lower flammability limit that Jose talked about earlier. Jose?
Awesome. Thank you, Don. Great things to know. Okay, myths, in fact, and Don kind of talked about this earlier. If a leak occurs, I have to remove the entire charge, fix the leak, and start again. And the fact is, no, since R454B is classified as a zeotrope, it does have glide, but it's 1.4 degrees Fahrenheit. That glide is so low, you top back off. You don't need to recover the entire refrigerant charge. So, something to know, service procedures are not going to change in that regard. So, Don, here's another one for you.
Okay, myth. We have to take another exam, an EPA exam. The fact is the A2Ls are regulated by the EPA, but there is no additional certification at this time. I want to stress that at this time needed. Those holding an EPA Section 608 certification will be grandfathered in and will not need to this. So looking back on the A2L time frame that we all lived through, that R22 410, I remember taking that test in the sheet metal room, and I remember going out in the parking lot and all of us loading our vet service trucks and going, man, I'm not putting that stuff in my truck. So we're already used to those pressures. But even when we took that little test there, it was not governed by the EPA. It was not regulated by the OEM. So it was the same thing. I foresee this being the same way. I could be wrong, but yet keep in mind there's not a test out there recognized by the federal or state level for R290, which is classified as an A3. So stay tuned on that. Okay. Next slide, Jose.
Awesome. So the next myth is I'm going to need to go run out and buy all new tools, right? Now, we'll talk in a second. There may be a couple you need to look at, but many of the tools you have today are already ready for 454B. If you have some current tools, they probably are A2L approved. They may be A2L approved if you bought them within the last few years. Best thing to do, contact the tool manufacturer. Go to their website, look up their service notes, and find out. If you take a look at these gauges here, this field piece gauges, and you notice right in the center, it's set for R54B scale. And if you look at the app that comes with it, it's R54B. And here are your suction superheat calculations, and here are your subcooling calculations. So looking down a list of these tools, I'm just going to focus on the ones that may change. So if we look at analog gauge manifolds here across the top, they just need to reflect saturation temperature. They're already designed to handle the pressure. Just that little dial in the center should show the temperature. Now that's if you're using that center temperature dial to calculate your superheat and subcooling. Personally, I've never really done that. I like to use a PT chart because I get better information, higher graduations in between. So I'm not looking at one line going, okay, is that 5 degrees or 3 degrees or whatever. But if you need to use your gauges or if you like to use analog gauges, just make sure they reflect R54B or R32. Moving one line down below that, digital gauge manifold probes need it set to the proper refrigerant. I have several different ones. Most of the ones I have were already set for 454B. One of them, I called the vendor. They simply needed a firmware update. So I downloaded some firmware, plugged in a memory card, and updated it, and now they read 454B. Everything else going down that list there, charging hoses, torque wrenches, flaring tools, scales, all same, business as usual. As we go down a little bit lower, we look at a vacuum pump. It just needs to be rated for R454B or R32, your A2L refrigerants, which the regulation there or the guideline there is that the switch is located away from the work zone, so it's not right next to the hoses. Most of your vacuum pumps or many of your vacuum pumps that are out there now already have that. If you're not sure, contact your manufacturer. Okay, fire extinguishers, they got to be chemical compatible, but I think most of us probably have chemical compatible fire extinguishers already. Leak detectors, of course, have to be A2L certified. They need to sniff that leak out. And recovery machines need to be 2L certified as well, right? But again, a lot of these are already there. So just contact your manufacturer, look up on their website and see, okay, do my tools meet the requirements for A2Ls? And this is just a screenshot. I grabbed many of the major manufacturers. We have, this is not a relationship Don or I have with any of them. This is just common knowledge. Fuel Piece's website, Appion, Yellow Jacket, Testo, Navac, all have tools rated for A2Ls, and they even have service notes that tell you what you need to do to get your tools rated to A2Ls. So look out for that. Okay, Don, I'm pass this one over to you.
Okay, sounds good. Hey, there's a myth out there. Can I add A2L refrigerants to a system designed for A1s? Absolutely not. A2L refrigerants will only be used in new equipment designed for A2L refrigerants. Okay, and later in this conversation, Jose is going to come over the reason why on some of these safety features. Do not add that to the A1 refrigerants. Okay, never mix a refrigerant. You just invented a new refrigerant. Okay. All right. Fact, they are not to be used in existing A1 systems. The following components have been redesigned for use of A2L refrigerants: the compressors, the expansion valves, the electric components, refrigerant charge. Okay. You're going to see a lot of these electrical components is going to be key around the outside of the industry, like, or the compressor and what have you outside in the system, like ream. And I think Jose is going to share some of that with you. You're going to see more coated type spades and those kind of things, contactors covered up and what have you, and everything moving forward. Okay, so it's apples and oranges. Please do not do it. You see what time and effort went into for liability on the tank design itself. You're going to see that when Jose presents it to the ream manufacturer and equipment, and you're just going to have to do the right thing when it comes down to the contractor. Just please do not do that. Okay. All right, Jose.
Awesome. Thank you, Don. Okay, now I'm going to turn this section over to Don. He's going to talk to us about refrigerant cylinders. So what's different, what's not changing, and things of that nature. So Don, I'll let you turn this. I'll turn this over to you.
Okay, very good. Well, first of all, we're getting away from colors. If you haven't heard, okay, most everyone's already seen the gray, off gray colored tanks now, and the reason for that is the concern was if the industry came up with an A2L refrigerant that was slightly off green to the green that's in the picture, a new technician might grab the wrong one and grab the A2L refrigerants. So that's key number one. Now, moving forward, your A1 refrigerants will be off gray. A2L refrigerants, on the other hand, as the picture shows in the R32 picture, that picture will be an A2L. Anything that is classified A2L will have a red ribbon or a red a band around it, if you will, on the top of it, as you can tell there. Okay, and that's not the only thing. Next slide. Couple other things here. We talked about the red band, so that's number one. The other thing is we went with an A2L cylinders will have left-handed threads, okay? You will need an adapter for that left-handed threads to convert it over to right-hand threads. But Don, why are we doing that? Well, as I know, and I know Jose knows, and if you travel around the nation teaching people like we do, there's thousands of technicians starting out in their careers every day out there. And sometimes those technicians are being put in positions that they're not quite ready for. And that's real world, okay? Moving up from preventive maintenance to service. So the thought process there was, hey, someone grabs the wrong tank, A2L tank, they don't know any better, or they're fairly new to the service side. They go to put their hoses on there, it doesn't go on. The hope is they'll call back to the office, service manager, whoever, wholesaler, and say, hey, I don't want to sound stupid, but this is happening. Hey, what color of tank is it? Is there a red ribbon around it? Yes, there is. Stop what you're doing. So that's my little story on that, my thought process from coming from the field myself. There will be two different types of adapters. One will be for tanks under 50 pounds, and one will be for over 50 pounds. And we'll have also an anti-counterfeit shrink wrap on the head of that. Now, it seems like a marketing thing, and I was suspicious of this a little bit myself, but here's the deal. We have a lot of bad actors out there, okay? A lot of refrigerants come in that aren't held to the scrutiny of some of the good players, if you will, out there. So here's the thought process on this. They're trying to figure out, the EPA is trying to figure out where all these emissions come from, okay? You're going to see that in some of the presentation later on. Things that used to be recommended are now going to be required. They're trying to figure out this kind of thing as far as where these emissions are all coming from, or these GWPs. So here's a thought that I have. When you put that self wrap around there, we here at Chemours, we get testing all the time. If refrigerant systems aren't running right, the last resort is let's test the refrigerant in it. Sometimes we find a refrigerant that's supposed to have three components in it has five, and one of them's like R125, which is half of 410A. That's a really high GWP. So that's the main reason for that around that shrink wrap to kind of keep everybody on the same playing field, if you will. And then last, A2L cylinders will have that relief valve safety, not a ruptured disc, as I talked about earlier, okay? So these are the things. It's all about liability, the steps to take in all those things as safe as possible to make this transition as easy as possible. Next slide, please. So cylinders, there was some conversation about cylinders. We know that A1 refrigerants are, we put them the way it's tooled in your truck right now. They lay on their side. The fun fact is on the box of years, the A1s were not supposed to be laid on their side. And the reason for that is that rupture disc and the proper procedure for a tank being laid on its side has always been, if you had the rupture disc, you want that at the 12 o'clock position. The idea is there, you want some kind of vapor barrier between that safety device of the tank so it won't go off with liquid hitting it unexpectedly for no reason at all. It has nothing to do with pressure or temperature, okay? It's just that liquid giving some kind of faulty thing. So that's fact number one. Fact number two is it's been stated that A2L refrigerant tanks are not allowed laid on the side, but Chemours has applied and was granted allowance for our materials. Now, I can only speak for our materials. Nationally applying and others cannot speak for them. It is a numbered and permit stamp that will be on the cylinders. So again, I can't speak for all other manufacturers, but Chemours applied and was granted a permit that will be stamped on the tank that you can lay 454B or any of the 454 series on their side. Okay, so that's great news. We tested it; it came back positive. We resubmitted it, and it passed with flying colors. So just a fun fact about that. Again, you still want that in that 12 o'clock position, that safety device, okay? Never at the 9, 3, or 6, all right? Turn it back over to you, Jose. Oh, I guess this is
Okay.
mine. I apologize.
Yeah.
Is this yours or mine?
No, you got this one, Don.
Okay, bud. Let's talk about refrigerant cylinders as far as the recovery. Recovery tanks, A2Ls, will be identified by a red stripe also, and will have a left-handed threads to differentiate them from the A1 recovery tanks. That's one. So it's pretty much same as the new A2L tanks. Never fill tanks more than 80%. Same as it was before with A1s. Nothing's changed there, okay? The formula to tell the cylinders is 80% full is to take the water capacity, WC, you can see it highlighted there, listed on the top of the tank, and multiply it by 0.80. Pretty easy stuff. We've done that all our life. Take the new value and the tare weight from the tank to it, place the cylinder on a scale always, and when it's reached that weight, it is full, okay? Never overfill a recovery tank. We all know that. Next slide, please.
Awesome. Thank you, Don. Okay, so I'm going to go ahead and start looking at installation and service. But before I do, I noticed there's a few questions ended up getting in the chat box. So I'm going to go ahead and read through them. Alex says, if it will not ignite under those conditions, why do we need to install sensors? And Alex, the best thing there is safety first. Okay. There's a lot of different nuances that go in there. Maybe if one space of the home is too small and it allows the refrigerant to pool or puddle up there, we want to be safe. We don't want anybody to get injured or have damages or lawsuits, things like that. We want to mitigate any risk possible. The next question that came up is, are the left-hand thread and relief valves exclusive to Chemours tanks? Don, do you have any other information on that?
I think I don't think I'm confident that the left-handed threads are pretty much across the board, and the relief tanks are so. That's something that's actually from the tanks. So everybody's under the same scrutiny there as far as that goes. Left-handed threads and the relief valves will be on all A2L tanks, as far as I know. I have not heard differently that. So
Okay,
yes.
great, thank you. Okay, and Rob asked, I want to clarify that the recovery cylinders and refrigerant cylinders relief valve is at 600 psi. That's the range. We really, in the industry, we talk more about temperature than we do pressure. So, but yeah, right around 600 psi, it'll open, release charge, and then reseal. Christine, want to know if this recording will be available via recording afterwards? Absolutely. At the end, I'm going to share with you a link. You can scan that with the QR code. And once you do, you'll be taken to a micro website that has the recording. It'll have a PDF handout of it and several other cool things you can use and download. Christine said, how does the LFL, MIE, HOC, and burning velocity of R410A compare with 454B? I don't have that handy. I would have to search that up. Dawn, do you know much about the differences there, or is that something we need to research as well?
What was that? What was the question again, Jose? I'm sorry.
Oh, the question was just how did the LFL, the MIE, the HOC, and burning velocity of 454B compare to R410A?
I don't have that answer for you. I'd have to do some research on that. But if you send your email or reach out to Jose at the end of this, I will definitely give you the answer. I do want to make a note here. I was going through my notes here, and I got to correct myself here. This was a conversation I had with our person that is in charge of tanks and what have you. And he says here, this was some time back. I was going through our conversation from months ago. The connections in left-hand, right-hand threads are not regulations, but suggestions. Equipment machines will not change, recovery units not changing, but they are the left-hand threads. It looks like they are going to go on the recovery machine, as far as I can tell. It could go either way on the left-hand or right-hand threads recover. Everything I'm hearing inside right now is it's going to be left-hand threads more than likely, but that has not been finalized. So I just want to make sure that, okay, but the left-handed threads was not required. It was recommended.
Awesome. Thank you, Don. Okay, a couple other questions here that came in. Chris wanted to know if there's a leak in the indoor coil. Will the unit shut down? How long will the customer be without heating or cooling? I'm going to ask you, Chris, just stand by. I've got some slides on that. Don't want to ignore your question, but I want to have the backup to show you what we're talking about. Dave asked, are there going to be 125 cylinders out there? As far as I've seen, I would say yes. Don, do you know, are there 125-pound cylinders available?
Yes, there are. Yeah, we have them already, and they will be out there. I do know that the 25-pound cylinders, what used to be 30 pound, the 25-pound cylinders are out in stock in most all the wholesalers right now. Whoever wants them on the 454B product, that is, I'm talking about. So
Awesome. Thank you. I just wanted to get confirmation from you because I am 99.9% sure I have seen those 125s in our research and development lab.
yes.
So yeah, they should be available to you guys out there. So thank you, everyone. Great questions. And if you have more coming in, just please let me know. So now we're going to talk about installation and service. And as we look at it, what I want to stress is that the procedures you use today to install a system, for the most part, are going to be the same when you're using an A2L refrigerant. I'm hoping to dispel that myth that the world's changing. It's really not. There's going to be some minor changes, but most of what you do will remain the same. So in the image here, we're just showing some different products. I do want to let you know that this A2L transition is going to apply to things like water heaters too, heat pump water heaters. So early adoption is going to be key for us. Refrigerant line sets. Okay, everybody's wondering, what about refrigerant line sets? Can you reuse them? Sure, you can reuse an existing line set as long as they are, and here's the caveat, they got to be properly sized. That doesn't matter about refrigerant. It wouldn't matter if it was 454B, R32, R134A. Refrigerant size pipe sizing has to match the design. The refrigerant piping needs to be flushed and clean. Now, as a manufacturer, what we're going to tell you is don't use a chemical flush. Not because we don't want you to use it, not because we think it's a bad idea. We do not know what it'll do to the insides of a system should there be any residual left in. So flush it and clean it with nitrogen, and we'll have a slide on that as well. The line set has to be pressure tested to the manufacturer's requirement and make sure that the pressure test holds. We don't have a leak. You want them free with leaks and always comply to local and national codes. Now, the next slide will touch on that just a little bit. Top image in the up top right is a national and local code. It could be enforced on retrofits. I don't know. So consult to local and manufacturer code, but you're going to need striker plates. That's not new. That's been there. It's just a striker plate. So if someone's driving a nail, a screw, they're not hitting the line set. Okay. And that has nothing to do with 454B. It's something that's been there to begin with. So it's going to provide protection from nails, screws, puncturing the lines. Now, your service valve connections, this is going to vary between manufacturers, maybe even through products and families, but the service ports in some way will be marked red for easy identification. This image I've got here shows some red locking caps on it. That's from our research and development facility. So just know this is an example. It's not it's not exactly what you may end up seeing later on. So I just wanted to give you some example of what we've seen. Pressure testing, you got to pressurize the line set, got to make sure it holds pressure for a specific period of time and it's leak free. I can speak for Rheem. Our recommendation is pressurize that line set to 500 psi and hold it for 60 minutes to prove that you're leak free. Now, when you're installing the line set or you're using the existing line set, always flush the line set. Sorry, slide malfunction here. Always flush the line set with dry nitrogen before making final connections. Sweep the nitrogen through to blow out any of the old contaminants, the old oil, the old debris, and any residual refrigerant. Purge with nitrogen through the lines and in one side and out the other. So as you see on the left-hand image here, this regulator is a dual-step regulator. So on the left, it's set to the purge function, which is pushing a higher pressure of nitrogen through the line set to blow the items out. Then notice on the right-hand side, we throttled it down to the braze section, which puts just enough PSI of nitrogen through to displace the oxygen. And by displacing the oxygen, we displace any soot or contaminant that could be built up. Okay, liquid line filter dryers need to be installed. This is not new. This has been a requirement technically all the way back to R22. We said it was a good idea to have a filter dryer. 410A, we said you needed to have one. It's going to be the same with 454B and other A2L refrigerants. Always install the liquid line filter dryer per manufacturer's specifications. And when you open up a system to atmosphere, replace the liquid line filter dryer. Remember, POE oil is hygroscopic, so it likes to absorb moisture. A vacuum pump will pull moisture out of a system, but not out of oil. The filter dryer will, so always replace the filter dryer. When it comes time to charging, all 400 series refrigerants, it's the same as it's ever been, need to be charged with a liquid. So if it's a disposable tank, you're going to flip that tank upside down. Then what you're going to do is you're going to take your refrigerant charging adapter, your liquid charge adapter, hook it up to the system, hook your gauges up to it, and feed your refrigerant in. The liquid charge adapter simply atomizes or splits the refrigerant from liquid to a vapor liquid mixture. So we're not dumping pure liquid onto the head of a compressor. Now, when you're charging, make sure you're charging according to weight. Figure out how much refrigerant you need to weigh in. Look at how much refrigerant the unit comes shipped with, how many feet of line set that's good for. Calculate your rest of your line set and add that charge amount. Then once you've added that charge amount via weight, you're going to trim the charge according to the manufacturer's guidelines. If it's a TXV, EXV, you're going to charge to subcooling, but you're always going to check the superheat. Subcooling tells you you've got the right volume of refrigerant. Superheat's going to tell you that the metering device is operating properly. Now, we know in other areas they do utilize reusable cylinders. Canada's using that a lot right now. If you are using a reusable cylinder for the refrigerant, maybe you pulled it out and you're putting it right back into the same system, which is allowed by the EPA. You're going to utilize the red port, which has a dip tube. That dip tube goes all the way to the bottom. It draws liquid out without needing to invert the cylinder. Analog gauges, again, you want to make sure the analog gauge has the proper temperature scale for the refrigerant being used. So I'm just going to zoom in on this pressure gauge right here. Notice there's your R454B, and this scale right here tells you saturation temperature based on pressure, which is the larger scale. So use the proper temperature scale for the refrigerant being used, and use the proper temperature pressure chart. I'm going to show you now. Chemours actually created something I've been using for years, an app that's really amazing. So, again, we have to charge the subcooling with a orifice, or I'm sorry, with a adjustable metering device like a TXV or an EXV. If you have a fixed orifice, I don't know how much of them are still out there. Those you charge by superheat, and then you check your subcooling. Calculation. We're not going to dive into a charging class here, but superheat calculation is that you take the suction line temperature that you measure with your pipe temperature sensor, whether it's a clamp or a thermocouple that you Velcro down. You take your suction line temperature and you minus it from your low side saturation temperature or your gauge temperature, and that calculates superheat. Subcooling, you use the high side. You're going to take the high side saturation temperature, which is the temperature on your gauge, and you're subtracting the liquid line temperature. Same process, we're just flipping which one is on top, which one's on bottom. Now, I do want to show you this. This is great. If you look at charging, Chemours has an app out there you can download. It's simply called PT Calc. You can go download that. It's an amazing app, right? So on the left, we're going to talk about checking superheat. On the right of the screen, we're going to talk about checking subcooling. So here's what we do. First thing you're going to do is come over and select your refrigerant. And this pressure temperature calculator has every refrigerant that I've seen in it. Then you're going to enter your low side pressure here on this enter pressure. It's going to give you your saturation temperature, and then you're going to subtract the two. Okay. That saturated vapor column you're looking at, because you're on the suction side of the system where it should all be a vapor. On the other side of the slide here, you see again, we're still using the XL41. We put in our high side pressure. It gives us our saturated liquid temperature. Then we do our subtraction with the line temperature. Really great. I wanted to show you this because remember, it's a zeotropic refrigerant. So there's two different points, a bubble and a dew. You can do it this way, or you can cheat and do it even simpler. If you look down at the bottom of these pressure temperature calculator app here, there's a box right here that says subcooling and a box right here that says superheat. All you do is enter your pressure and your line temperature. It does all the math for you. So grab that app. It's incredible on what it can do for you. Digital gauges, again, set the gauges to the proper refrigerant scale and let the gauges do the math for you. Your 454B, whether these are gauges or probes, set the right refrigerant and let it do the math for you. When it comes time to evacuate the system, same as it ever was, right? You're going to use an A2L approved vacuum pump. If you don't know if yours is A2L approved, check with your manufacturer. Okay, triple evacuate the system is what we like to recommend, where you evacuate the system down to 2,500 microns. Once you reach 2,500 microns, you pressurize the system with dry nitrogen, push it in through one side, open it up later, and let it sweep stuff out back down to 0 psi. Then the second step is you're going to go ahead and evacuate the system to 1,500 microns. Once it's reached 1,500 microns, pressurize the system with dry nitrogen again, sweep the nitrogen out to get back down to 0 psi. Then evacuate the system the third time, pulling down to 500 microns or less. Then hold that pressure at that micron level at 500 microns without climbing. You need to hold that for at least 30 minutes to prove it's a tight and dry system. Now, the rule of thumb has always been that if it climbed from 500 up to, say, around 750, it was a wet system. You still had moisture in it. If it climbs from 500 to over 750, 1,000, things like that, you've got a system that's got a leak in it, okay? So, again, cool down to 500 microns and let it sit for at least 30 minutes. Okay, we do have a couple questions that came in. Will units be shipped with nitrogen holding charge like current units with a 15-foot line set with a 15-foot charge? The units will become shipping with refrigerant. There will not be dry charge units that I know of at this point. Now, things can change. I'm not going to say to that, but I know that we're looking at shipping with the refrigerant. The question came in from the app again. The app is called PT Calc. And there you go, Chemours PT Calc. Great app, lots of really awesome features to it. And when we talk about micron gauges, you may be thinking, why is it so important to do a micron gauge? So if you look at this gauge on the right-hand side and you see those green increments, that's our vacuum level. Each line represents 2,036 inches of mercury vacuum, or 50,800 microns. Very small scales. If you look over to the right here, notice that when you reach 29.32 inches of mercury, you have 15,240 microns. Okay. Now, jump down to 29.74, you're at 4,572 microns. Jump down to 29.92, which is as close as you're probably going to get. That's 500 microns. So between 29.32 on that gauge and 21 and 29.92, you visibly cannot see it. The micron gauge has to be there to give you that insight. Okay. All technicians working with A2L refrigerants, they've got to be certified with Section 608 of the EPA. The recovery machine and the tank need to be certified for use with A2Ls. A lot of your machines are already approved. Contact the manufacturer if you don't know. The A2L recovery tanks are going to be identified by that red stripe, and they should have left-handed threads to differentiate. And again, like Don mentioned, don't fill the recovery tanks more than 80% full. That's not new. That's always been there. Okay. So, and there's the capacity there, the formula there on the bottom. And those numbers you need, the water column or the water capacity and the tare weight, they're on the side of the tank. Water capacity is how much refrigerant can it hold. Tare weight is the weight of the tank by itself completely empty. So you're going to take the water capacity, the max it can hold, times 0.80, because we only want to fill it 80%, add the tare weight of the tank, pop it on a scale, and in this example, when this tank reaches 54.68 pounds, it's 80% full. Refrigerant oil, again, we're going to use POE oil and polyester oil. They're all going to use them. When you replace a unit, flush out the line set to get that old oil out, just because we don't know if it's got contaminants in it or how much moisture it has absorbed. And again, vacuum pumps aren't going to pull the moisture out of the oil. That's what that filter dryer is there for. And again, you replace the liquid line filter dryer whenever you open the system. If you're going to buy oil, for some reason you need to add oil, and I could count on one hand how many times I've ever had to add or change oil to a system. Purchase the oil in the smallest volume you can and purchase it in metal containers, because moisture likes to seep through plastics. All plastics have a certain permeability to them. So use the oil that's properly for it. Now, here's what changes a little bit. Depending on what refrigerant you're going to use, that's going to change not the type of oil, but the grade of oil. So R54B, because of that lower discharge temperature, is going to use grade 32 oil, or viscosity of 32. R32, because of that higher discharge temperature, is going to use grade 46 oil. That's for your awareness, but in reality, how many times are you ever going to have to add, remove, or change oil? As Don mentioned earlier, this oil is not like you have in a car. It doesn't break down. It doesn't leak out if we have a tight sealed system. So some information on refrigerant oil, but nothing that's going to be really game changing for you. When it comes to leak detection, make sure your leak detector can detect A2L refrigerants. There's multiple types out there, like heated diode and infrared. They're probably the industry's most utilized or most accepted ones that are out there. Just make sure it's rated for A2Ls, so consult your tool manufacturer for it. Now, AHRI's report concluded that infrared sensors are most likely the most practical option, maybe because of cost, availability. Reach out to your manufacturer if you don't know for sure. And this is nothing new, but don't use a halide torch as a leak detector. That was a torch that had an open flame. As you moved your hose around, it looked for certain elements in the refrigerant makeup, and the flame changed color to let you know there's a leak. Didn't work with R410A because that value wasn't there, and we don't want to use it with R454B or R32. It's not going to give you what you need. Okay, so installation summary, as Don mentioned, there's some required practices. And then there's some recommended, right? So let's look at the differences between A1s on the left and A2Ls on the right. Safely remove the refrigerant following local codes and national guidelines required for both refrigerants. Purge the circuit with an inert gas before doing any work. That was the best practice on A1. A2Ls required. Purge that line set, purge that system of A2L refrigerants and gases before doing any work. Evacuate the circuits. That's going to be a best practice with the A1s. Really, you had to remove moisture. It's required with A2Ls. Opening up a circuit by cutting components out. That's always been a best practice. Because if you have a liquid line filter dryer, you put a torch to it to sweat it out. Here's the thing. A liquid line filter dryer's job is to hold liquid. You put a torch to it, you start to evaporate that liquid. Where's that liquid going to go? Right back into your system. So best practice on A1s required for A2Ls. Make repairs purging with nitrogen while brazing, required and required. You got to keep that oxidation from occurring and creating soot. Leak and pressure test. It was a best practice for A1s, required for A2Ls. System evacuation, required and required. Cylinder head threads, right-handed versus left-handed threads. That covers the installation section. Now I'm going to look at the questions here. Got a couple questions come in. Zoom lock on A2L. Chris, when it comes to zoom lock or mechanical fittings, really those are treated like the same way as a brazed fitting. They're something that's installed in the field. So if one leaks, it's gonna be part of the way the installation of the preparation was done. So I know that we have not taken a stance that we're going to disallow use of mechanical fittings. So business as usual in that regards. Okay. All right, so moving on into safety here. Again, it's a mildly flammable refrigerant, so you're only using it in equipment rated for A2Ls. You got to be compliant with safety regulations and code standards. We'll show you that here. Never pull a non-flammable refrigerant out and put in an A2L. They're not drop-ins, right? You can't pull 410A out and put R454B in. Okay, the cylinders are going to have the red stripes, and they're going to be marked with labels so that you know what you're working with. Here's the key. Manufacturers go and put lots of hours and money into building installation manuals, right? Installation and operation manuals. Refer to them, right? Use them. Don't charge 454B into a system that's got R410A. Make sure you have adequate ventilation. Now, some people thought, okay, I have to ventilate because it's flammable and it's going to combust. No, not necessarily. That's not the only reason why. But as Don mentioned, all refrigerants are heavier than air. They will pool. They will displace oxygen. If you're in a confined space, ventilate so that doesn't happen. Minimize any ignition sources. Use dry nitrogen as a gas. Don't ever pressurize anything with oxygen, right? Sure, the field accessories are approved by the manufacturer and they're rated for A2Ls. And then keep track of the refrigerant you add and remove on the system so that you know what you're putting in. The person behind you knows how much charge is in that system. When it comes to refrigerant quality, beware of counterfeits. Look for those seals around them. Always buy refrigerants from a reputable source. Now, when you're getting rid of a cylinder that had A2L refrigerant in it, in the past, we would puncture a hole in the rupture disc. Don't do that because that's not a rupture disc. That's a spring-loaded safety relief valve. You don't want to do that. So find a spot on the side of the tank. Use a non-sparking method to rupture the disc, making it unavailable for use. So what are manufacturers doing? And each manufacturer may have a different way that they're doing it, but there's these things that are basically going to be a standard. We're minimizing the refrigerant charge. We're putting less refrigerant in the system. That could be through redesigns like what we're doing with 7mm condenser coils that hold less volume, but you're minimizing the amount of refrigerant charge. Then components that are electrical are being sealed. They're sealed electrical components. Like you see on this screen here, that contactor has got sealed connections so the spark isn't near the refrigerant. The equipment's going to be labeled, that A2L flammable label on it. The system will require you to complete the total charge that you've written on the system. And then refrigerant leak detector is going to be used kind of like was asked earlier. So let's take a look at that. Now, refrigerant leak detection is going to be required. Now, the type of sensor used is going to vary from different manufacturers, right? Whether it's infrared sensors, thermal conductivity, or another, the thermal conductivity infrared are the most common types of sensors out there. The key thing is how the system detects refrigerant to us isn't as important as how it's connected. Okay. So that's the thermal conductivity of the infrared really doesn't matter. It's that the sensor's there. They're going to be installed by the indoor coil and near the lowest point of the indoor coil because, again, refrigerant's heavier than air, and it's going to want to pool. Now, the leak detection sensors, if you look at one, it may say rated for R32 on it. But remember, R454B is 68% R32, so it's going to pick up a leak of R454B. Now, sequence of operations. The sensors will lock out the compressor and energize the constant fan when a leak is detected to prevent a buildup of refrigerant in the space. These sensors may be factory installed or field installed. This is going to vary between manufacturers or vary through product lines. Factory installed sensors typically come shipped for upflow configurations like you see here. This sensor's in the bottom. When I lay this coil on its left-hand side, that's no longer the bottom. That's now the top of the coil. So you see that we will have a spot for you to relocate the sensor. They'll be pre-marked, pre-drilled, so you can move your sensor over. So let's just show a sample of how this is wired. This is a real basic line art drawing. This is not a complete schematic. Just want to show you how this is wired. So what you're going to see is I bring in these lines. Down here at the bottom of the indoor control board, this is the furnace control board here. Across the top is your thermostat. On the right-hand side is your outdoor unit connection points. Down here is a 24-volt relay that Ream's going to use in our coils, in our equipment. And then down here are the terminals of the A2L sensor. You're going to notice as we look at the furnace board, there's a secondary and a common connection that provides 24 volts. Those 24 volts are going to run over to the 24 volt C and 24 volt B connection on the sensor. Now, the minute they do that, remember, as you add voltage to a relay, positions are going to change. So we'll talk more about that in a second. But what you see is normally closed contacts on this slide are now going to change to the normally open position once the sensor is energized. Okay, so the next thing that's going to occur is we're going to send power out of the normally open, which now is closed, portion of the sensor up to the inlet side of the coil for the relay. Next thing that's going to happen, 24 volts common is going to come up and go to the other side of the relay. Now, as soon as that relay is energized, this contact right here that's normally closed is going to change to normally open. That's important for us on this next step. The next step is that the thermostat calls for Y1, and a wire from Y1 is brought to the common terminal of the 24-volt relay. Now, it's important to know that common on a relay is not common potential like common on a transformer. It's simply common connection, meaning that that terminal is common to the open and the closed points. Okay. Now, remember the relay has switched from normally closed to normally open, so we're going to send a signal out on this normally open connection. That's going to come to a connection point, a wire nut on the indoor unit, and then that is going to send power out to Y1 on the outdoor unit. So this sensor's powered up, the system's ready to run, okay? Now it detects a leak. The first thing it's going to do when it detects a leak is shut down that outdoor unit by this relay changing position. But notice we now have a normally closed contact on the sensor, which changes to normally open. And now we're going to move over and send 24 volts to the G terminal, energizing the constant fan. That's with what we refer to at Ream as a legacy thermostat or a 24-volt thermostat and how that's going to integrate. Okay, now the question is, what about fully communicating systems? There's going to be a connection point, a dry contact or something that allows the communicating thermostat to see a leak, and it'll generate a fault code. Something that notifies the homeowner of a system error, but it's not going to tell them we're filling up your house with mildly flammable refrigerant. It's going to be something to alert the service technician of what to look for. Now, the question that we saw on the screen earlier is, what about how long the system's going to lock out? So when the system shuts down, of course, your suction pressure is going to rise. That higher pressure will cause more of it to leak out, and that's designed so that we can get that refrigerant moving out of there. The sensor will be shut off, and it'll stay shut off for 5 minutes after the leak has dissipated. Once the leak is dissipated, the system will be allowed to run again. Okay, so just kind of that's how that works. Now, that's not set 100% in concrete. It may vary. The timing, the logic may vary between manufacturers. So be aware, but that's a rough idea, a sample idea of how these things might work. Now, when it comes to packaged products, Just know a packaged product will operate in a similar manner. It may only have one sensor. Larger products may have two or more sensors. If they have one sensor, normal operation. If we have two or more, they're simply wired in series, so any sensor can trigger the leak detection protocol. Now, whether you have a direct digital control system, a DDC system, or a non-DDC system that's just using relays, the way they're wired and integrated will vary, okay? And vary by manufacturer as well. What we're doing at Ream is if we have a system with an economizer, that economizer, when that leak detection occurs, the economizer sees that, and the economizer is going to go to the minimum fresh air open position to bring fresh air in to help dilute the mixture as well. So what do you need to do as contractors? Bullet point one, always follow the installation and service procedures, right? Ventilate your work areas. Realistically, this is no different than what you should be doing already because of the way of refrigerants are being heavier than air. Purge the line sets before you braze. Braze with nitrogen flowing to prevent soot from being built up in the system that's going to clog a metering device. Ensure the leak detection sensors are properly installed and operational, and never bypass a sensor. You don't want to grab that liability. Always weigh in the refrigerant charge and then charge to subcooling or superheat as needed. Always weigh in the charge so you know how much is in there. Use OEM parts to ensure your safe operation. Don't take a non-sparking component out and put a sparking component in. Yeah, we went through how hard it is to get this to ignite, but the what if says always use best safety practices. Stay educated, right? Train yourself, train your staff, and you'll see in the next few slides that we have created resources to help you educate your staff. Know your surroundings, know your local codes. Whether that refers to the type of locking caps you need, striker plates, whatever those local and national codes are, be aware and be advised, right? Installation, and this is the last bullet point, is something I want to mention because there's different talks about how much space you can have with refrigerant. What's the smallest space, right? If you have a space that's small and you're worried about refrigerant pooling in that area, there's something we've been doing for years. You can install a jumper duct or transfer grill. So let's say you have a really small bedroom or a really small storage room and it has a vent in it, and you're worried about too much refrigerant pooling up in that area, create a jumper duct. A duct that goes from that smaller space to a larger space. You've essentially increased that size, okay? Minimize that risk. Transfer grills and doors will do the same thing. Now, here's a great slide. It comes from the AHRI, A2L Equipment Best Practices. You can Google that, their SNAP site, and these are practices that they give you. Before installing a service equipment, basically all the things we've talked about, right? Installation, A2L evacuation, A2L charging, A2L system repairs, A2L recovery. Basically everything Don and I have been talking to you about is here summarized in this page, so that's another place you can go look. Now we're going to walk you through a few review questions just so that we've covered kind of the things we've been discussing, okay? So Don, here's review question number one. You want to tackle this for the group?
Sure. Hey, that's great information you just shared there, Jose. Very informational. So let's look at this first review question. A2L refrigerants cannot be used as a drop-in replacement for existing A1 refrigerant systems. Is that true or false?
Nope.
In the
Get the clicker here, sorry.
That's all right. The answer is true. Components in the system designed for A1 refrigerants are not designed for A2L refrigerants. First of all, you don't want to mix refrigerant. I kind of cringe, and I think most trainers do, and technicians, when we hear about drop-in. There really is no such thing as a drop-in. You're always removing those refrigerants. When we back in the day of R22, we went to Mo 99 or New 22 or 407C. Always have to replace that, take that refrigerant out, clean the system up, and then put it in there. Make sure that, and I know a lot of people don't like that term, but just want to make sure we're clear on that. Okay, thanks.
All right, now as we look at the next question here, the question is, which of the following refrigerants has the most similar operating pressures and temperatures to R410A? Is it 32, R449A, R454B, or R1234YF? And that answer is going to be R454B. Operating pressures and temperatures are very close to R410A. In what we saw, they're actually a little bit lower pressures, so it makes for an easier installation for technicians. So we'll jump over to this next one, Don.
Okay, what type of oil will Rheem use in A2L, its A2L products? Mineral oil, polyester oil, alkylbenzene, or all of the above? And the answer is Polyester oil, POE. As Jose said earlier, the POE will be the same as it was for 410A, POE 32. If you're moving to the R32, as Jose said, it runs a little hotter, causes a little more friction. They're going to go with a POE 46. I would refer you back to Emerson's AE Bulletin 93-11. Okay? Thanks.
Awesome. Okay. And the next question is R54B is a blended refrigerant made of 1234YF and R32, and it does not contain hydrocarbons. Is that true or false? Well, the answer is true. And if you want the mixture, remember it's a zeotropic blend with a very low glide of 1.4 degrees Fahrenheit, and it's 68.9% R32 and 31.1% R1234YF. All right, here we go, Don. The next question.
Okay, which of these items cannot ignite A2L refrigerants? Let's see if we were paying attention. 1, toaster. 2, cigarette. And 3, typical static electricity. Or all the above. Drum roll, please. That would be all the above, as Jose was telling you about that, okay? While A2L refrigerants are mildly flammable, they are hard to ignite in normal daily situations, okay? Go ahead, Jose.
All right, and A2L refrigerants can only be used in systems rated for A2L refrigerants. Is that true or false? And of course, the answer is going to be true. The internal components in A1 systems, compressors, expansion valves, accumulators, whatever those components are, they're not rated and tested for A2L refrigerants. So we've got to make sure that we're only using A2L refrigerants in A2L systems. And
Okay,
here's you,
A2L.
Don.
Yeah, A2L refrigerant cylinders have what color band at the top of them? Is it green, yellow, orange, or red? Answer, please. And that answer is going to be red, of course. A2L refrigerant cylinders will be off gray with a red stripe or a red ribbon, however you want to look at that, around the top of it, identifying as an A2L.
Awesome, awesome. Okay, the next one, how might A2L systems be different from A1 systems? Are they incorporating onboard leak detection? Do they have protective electrical equipment enclosures, flammable refrigerant labels, or all above? And that answer is going to be all of the above. Maybe some more that you'll see out there, but all of the above. Okay. And here you go, Don.
Okay, 454B systems refrigerant charge can be topped off after leaks are repaired. And the answer is true, same as it ever was. Okay, 454B will think so. Don't worry about the glide or the fractionalization. It's the same thing. In fact, as Jose said earlier, all we've done with the 454B is quite simple. We moved it from 50% to 68%. Let's just say 70% for the sake of not arguing, and drop 30% in that 1234YF, another Chemours product that we use in cars. So it's pretty simple, pretty much business as usual.
Awesome. Very cool. All right. So refrigerant recovery tanks for A2L refrigerants are identical to A1 refrigerants. Is that true or false? Refrigerant tanks, is that true or false? And it's false. A2L refrigerant tanks, recovery tanks, will be marked with a red stripe. The rupture disc will be replaced with a pressure relief valve. And that wraps up our review questions. So in summary, A2L refrigerants have been adopted and are used in many products out there today. Many, right? A2Ls are listed as mildly flammable, but they're extremely hard to ignite. They contain no hydrocarbons, right? Installation practices, service practices, safety practices, and handling practices are very similar to what you're already doing today. And then the last key on that summary is early adoption of the items we discussed is going to prepare you for a successful transition. Okay, now I want to show some additional resources here. First and foremost, this QR code, if you scan it, will take you to a microsite. That microsite will have an online quiz that you can take. Once you take that online quiz, you will get a NATE certificate with your name, the date, and the NATE number on it that you can then go to NATE's website, upload that certificate for continuing education credit. Now, with NATE, the ruling is now that you need 16 hours of continuing education within a 2-year period. This is going to give you 2 hours of continuing education. You're going to have a one-page document of key takeaways, right? A one-page document you download. And when you download it, it'll show the key highlights for service, safety, best practices. All of those things are going to be listed on it. And every one of the QR codes I'm showing you here today is on the bottom of that one-page downloadable document. There will be a downloadable A2L readiness quiz. So if you don't want all your employees, or if you want another way for your employees to get tested, download this quiz. It'll be a 3-page document. Page 1 and page 2 are the quiz. Page 3 is your answer key. Test the readiness of your own crew. Have fun with it. Enjoy the continuing education they give. And also at the end of the day, I will have the webinar recording loaded so you can go back and watch this and share this link with anyone and everyone that you may have come in contact with. So that's that link. Go ahead and download that, and you'll have some great information on it. Okay, so if you have a problem with your browser, some phones, some tablets have a problem loading the quiz on their browser, depending on the version of software. Scan this QR code. Some cell phone browsers may not support that quiz completely. This will take you directly to the online quiz so you can get your NATE certificate and get those 2 hours of continuing education. All right, now this site here, this QR code is going to take you to Chemours Opteon website. Amazing, amazing resources there, videos, links, downloadable documents, calculators, and I think, Don, you said there's some new stuff that just came out recently on that site as well.
Yeah, actually, just I'm going to say in the last 3 weeks or so, if you go to option.com, there'll be a training drop down, and you can go there and request training for your group, company, or organization, or a lot of stuff that's on demand. You'll see you can do remote type training. We have all kinds of things. We have a pretty decent team of sales, technical people, myself included. So go ahead and do that. The last thing I'd like to plug too is Dr. Chuck Allgood. Go to Opteon.com's YouTube channel. Dr. Chuck does about a minute, 30, 45-second videos, I believe. Real easy to digest of things basically that Jose and I have talked about all morning long. So if you go there, he just talks about like what's an HFO or what's this or what's that. And it's real easy to digest, and you can get on your way the rest of the day. Okay. Thanks, Jose.
Awesome, and great point, Don, with those Dr. Chuck videos. They're really easy to understand. Dr. Chuck has this amazing gift of taking the complex and making it simple for us. And this is where I got a lot of my data from, was just listening to those videos and watching those videos. Okay,
Absolutely.
the next resource that want you guys to share. We did mention that there's no required certification at this point from EPA for A2L refrigerants, but ESCO Institute, who is focused on educating the industry, they did create their own booklet and their own online quiz. Now, the booklet's fairly inexpensive for the amount of data that's in it. Go to their website and see the updated pricing. QR code will take you there. The book is amazing. It covers all low global warming potential refrigerants. So it even has information about A3s in there should you need it. And then you can take the online course and get your certification from ESCO Institute. Now, again, it's not a manufacturer required certificate. It's not an EPA required certificate, but it's one more thing to put in your toolbox of education. So that's the ESCO Institute low GWP refrigerant safety. Okay? They're not the only ones, right? If we go to NATE's website, North American Technician Excellence, scan that QR code. At this point in time, that book that they get, the Low GWP Refrigerants Guide, is a $20 book that covers all low GWP refrigerants. And a lot of the things that Dawn and I talked about today, I extracted information from these guys, right? Some great data there. So that's the NATE site. As we move on, ACA as well is reaching out to educate the industry. I don't want you to sit back and think there's a transition coming and there's no places I can learn more. ACA has their Q-Tech training series. It's an online on-demand training series. Again, you can go into Q-Tech. You don't have to be a member of ACA. You can purchase the course, watch the course, take the test, and get your ACA certification from it. Again, not an EPA certification, more of a certificate of completion, but it shows that you have educated yourself. And that's the one thing that's so important in whatever we do in life, is we need to continually sharpen our saw. So when we need to go do the work, our tools are ready. In this case, our tools are our education. Okay, so I think we've got a few more questions in the Q&A box. I'm going to go ahead and run through. One of the questions was refrigerant charge ratio compared to R410A. And I'm not going to pretend to know that. That's going to vary based on manufacturer and product family and capacity. So product capacity tonnage, that's going to vary. There's no one fixed number that I could say to that. Let me go look in the Q&A box here. Zach wants to know, will service valves be swedged or are they going to be straight fittings? Zach, that depends on the manufacturer and the product family. Okay, but do know that you could see both. It would just depend on the manufacturer. Curtis wants to know, will there be multiple stage condensers with new refrigerants? Curtis, that's going to depend on the product family and the design. I don't have answers to that right now. As products start to launch, as we get closer to that 2025 deadline, we'll know more about that. Pat wants to know, will there be ventilation requirements when a leak is detected like they're doing on the refrigeration side? Right now, and of course I have to say right now because that's currently what we know, the standard is to shut off the system and run the fan constantly to purge the refrigerant from pulling up in one general area. What that looks like in the future, it could change, but that's kind of what we're doing right now.
Yeah. Yeah. If I can add to that just a little bit, you're going to have different types of mitigation strategies. So as Jose said, we're going to fall under that M1, which is that minimum going to be a sensor of some sort. And then the fan coming on, as Jose said. Mitigation 2 gets a little more complex depending on the charge and the application, as Jose said, and that gets into how is the building being used. So you might have to bring fresh air into that room when all those bells and whistles go off. You might see solenoid valves where it's pumping it outside to the condenser outside the building, but that's not definite. Any of that's definite yet. It's just up in the air that you may see those things, as Jose said.
Absolutely, Don. Great. Rob came in with a question: what's going to make a technician install a field installed sensor? Well, what should make them is the law. It's required and wanting to minimize their risk. Okay. Now, there may be some who don't, but I don't want to be that technician to take that liability upon myself. Tyler wants to know, will shipping equipment with A2L refrigerants change the hazmat classification, therefore raising freight charges on equipment? I think Don covered this, so I'm going to let Don chime in a little bit as well. But what he said on his slide was business as usual for your service vehicles. There's not going to be hazmat placards until you exceed over 400 pounds. And if you can fit 400 pounds of it in a service van, you're not really driving a van anymore, right? As that cost for shipping freight, I think some of that will depend on where the product's coming from, where it's going to. But I don't know that there's much change in hazmat requirements. Don, are you aware of anything like that at this point?
On service vehicles, as we said earlier, it's business as usual. It's like 440 pounds. Now, that's not one tank. That includes your settling, anything that's on the tank, whether it's A2Ls or whatever, A3s or anything like that. You will not need any type of ventilation inside those service fans, and there won't be any placards. Now, when you go to box trucks, semis, and other things, there will be placards required. Other than that, I haven't heard anything differently than what we're doing today. Okay.
Awesome. Thank you, Don. Question is, what happens from Curtis? What happens if you do not use nitrogen to braze with the A2L? What's going to happen with A2L not brazing with nitrogen is the same thing that happens with 410A, 134, 1234Y. If any of your refrigerants, you're going to have oxygen in the pipe. As soon as you open up the system, oxygen floods in. Oxygen burns and creates soot and carbon. That carbon builds up on the inner walls of the pipe. Refrigerant is a natural degreaser. So as the refrigerant flows through the pipe, all that soot and carbon's coming off. It goes right into your valves, right into your strainers, right into your orifices, and this is how we create restrictions. So we want to make sure we don't do that. Josh asked, can we please get a copy of the recorded presentation? Absolutely. That is that QR code that I sent. And once we shut down the screen sharing, I will paste the link in case you just want to click on your computer or your browser. I will paste the link to that downloadable site that houses everything that we look at. Mark came in and said, will you be able to leave service ports soldered into a sealed system after servicing window and AC P-TAC type units? I'm going to be honest, Mark, I don't know about that. I know what I was understand to be the old standard was service valves on sealed systems were there to access the refrigerant and then be removed. That was the standard that I learned when I took my EPA exam. So I'm not going to say that I know the answer on that. It might be better to reach out to a manufacturer of small products like window units, refrigerators, or P-TACs to see if they have some information there. So yeah, and I think we've answered the rest of these questions. So I appreciate everyone's attendance. I thank you. If you want to reach out to me with questions, there's my email address. And I want to thank you again for coming and being educated. Don, you have any closing words for the audience?
Just thank you and thank Reem for inviting Chemours to be a part of this and supporting the R454B product. We really want this transition, as Reem does, to be as smoothly as possible. On a personal note, from the School of Don Gillis, I've said this all around wherever I teach at. I honestly feel, I could be wrong, but I honestly feel that this transition from 410A to 454B is going to be smoother than it was from R22 to 410A. I truly believe that. And the only difference here is it's a little shorter runway. We're getting there a lot quicker than we did with 22 to 410A. But as an industry, we're tough people. We can do this. We can make this happen. So don't fret it. Just embrace it and you'll be all right. Okay. Best practices. That's all it is. It's really just best practice, pretty much, as Jose said. Thanks again, Jose.
Yeah. Thank you so much, Don. Thanks for taking the time with us. I want to thank everyone for taking the time out of your day. We know time is precious. Appreciate you learning. Feel free to reach out to us. And once I stop sharing screen, if you'll give me just a second, I will post the link to those sites in the webinar chat for you. Once you get those links, feel free to log out and have a wonderful day. Thank you, everyone.